In this video for section 3.1, we're going to talk about what are called measures of center of a data set. They tell us where the middle or a typical value in the data set is. So the first measure of center that we're going to talk about is the mean. To calculate the mean, we add the values and divide by how many data values we have. We have two symbols for the mean that we're going to see in this class. The first is mu, which is a Greek letter mu. And we use mu if we are finding the mean of a population or referring to the mean of a population. We use the symbol x bar, which is an x with a horizontal line across the top if we're talking about the mean of a sample. And remember, population is the entire group that we're interested in, and a sample is a smaller group taken out of that larger group. So looking at example 3.2, we have a sample of 7 university professors, and we have their annual salaries, and here's the sample data. We want to calculate the mean of the sample data. Now I could do this by adding all the numbers and dividing by 7. I'm going to show you how to do it in Minitab. So I've already entered the data here. It didn't take very long because there were only 7 values. Now I'm going to go to Stat at the top, go to Basic Statistics, and Display Descriptive Statistics. My column that the data is in is C1. I click on Statistics, and I am only interested in the mean for this, so I'm going to uncheck all of the other boxes. And here's my mean, $170,571. And this is x bar because it's a sample. It's not the entire population of all professors in Wisconsin. It's a sample of only 7 of those professors. So that's the mean of the sample data. Now, one disadvantage of the mean is that it can be affected by extreme values. So in example 3.3, we're going to suppose that the salary recorded as $316,000 was actually $1 million. We're going to see how the mean is affected. So I'm going to go to my spreadsheet, and I'm going to paste the data into a second column and change the value of $316,000 to $1 million. Now I'm going to run the calculation again. So Stat, Basic Statistics, and the column that I'm interested in now is C2. If I click on Statistics, the options that I selected before should still be in effect, so I have the mean selected, which is what I want. And now the mean is 268,286. So the mean increased by a lot. If I compare this to my previous value, I can see that it is almost $100,000 more. And it actually is now larger than all of the data values except for that $1 million value. So if I look at my data values here, they are all less than 286,000 except for that 1 million. So the mean was very affected by the extreme value. The median is another way that we can measure the center of a data set, and it arranges the data values in order from least to greatest. The median is the middle value. If there are 2 values in the middle, then we take the average of those 2. So for example 3.4, we want to find the median of our data set of salaries. I'm going to show you how to do it in Minitab. You could do it by hand if you like. You would put the numbers in order, so 98,000, 100,000, etc., all the way up to 316,000. And then normally what people do is they kind of cross off one from each side until they get to the middle. Using Minitab, I'm going to do my statistics calculation again. Now I'm going back to my original data set in C1, and instead of mean, I want to calculate the median. So I get a median value of $155,000. That's the middle value in this data set. You could probably figure it out, pretty easily by hand if you want. That's this 155. There are 3 values below that and 3 values above that. Sometimes we use a capital M for median. That's not always the case, but I think you'll see that in some of the homework problems. So that's my median. Thinking about how the mean and median compare to each other, if we have a symmetric data set, so the data is evenly spread on both sides of the center, then the mean and median will be about the same. So that's going to look like this choice C over here. They may not be exactly the same, but they should be about the same. If the data set has a tail on one side, then we call it skewed. And the direction of the skew is always the side that the tail is on. So this left skewed means that on the left side of the data, there is a tail. Now notice it's the tail, which is kind of a long and low part of the graph, not where the peak of the graph is. This is left skewed, but the peak is on the right side of the graph and the tail is on the left. Right skewed means that the tail is on the right of the graph. Now, what the tail does is it pulls the mean in the direction of the tail, but not the median. So we say that the mean follows the tail. So if the graph is right skewed, the mean will be greater than the median. If a graph is left skewed, then the mean will be less than the median. So if we have a symmetric data set, we could use the mean as our measure of center, but if the data set is skewed, the median is a better choice because as you can see from these red lines, the median more accurately reflects the peak of the graph. So both of these, when it's skewed, the median is closer to where the peak of the graph is. And these lower values have more of an effect on the mean than the median. So for example 3.5, we want to again change that value of 316,000 to 1 million and see how the mean is affected. So now I'm going to run my same calculation for column 2. We're calculating the median. And looking at this, the median was not affected at all. It's still 155,000. So the median was not affected by changing that data value, while the mean was very much affected by changing that data value. And the reason that the median is not affected is because 155,000 is still the middle value in the data set. And that is because the 316 was the largest value in the data set. So changing that to 1 million did not at all affect which value was in the middle because it was already the largest value. So my median did not change at all. And our last measure of center here is the mode. The mode is the data value that occurs most frequently. Unlike the mean and median, you could have no mode, one mode, or more than one mode in a data set. No mode means that each value occurs the same number of times. Probably it would be each value occurring once. So if we look at this first data set, each value occurs exactly once. The second data set has a mode of 4.9. That's because 4.9 occurs the most in the data set. 4.9 occurs 3 times, 6.3 occurs twice, and 8.9 only occurs once. And the last data set here has 2 modes, 43 and 28, because both of them occur twice, and so it's a tie for the most frequently occurring value. And those are measures of center for a data set.